In this lecture, we're going to cover streams and reactive programming. By the end of this lecture, you will know what streams are and how to think about things that happen in an application as streams. And you'll also know what reactive programming is and how to start transforming your way of thinking from imperative to reactive. So streams are a sequence of values over time. That's it. For example, a number that goes up by 1 every second might have a stream that looks like this. 0, 1, 2, 3, 4, and then 5, 6, 7, 8. Another stream might be a sequence of X and Y positions of mouse clicks. We could even have a stream to represent a user filling in a form on a website. We could have a stream to represent each key press, like this, A, then S, then I, then M. Or we could have a stream which contains a JSON representation of the whole form as the user is entering data. Like in this one, the user is entering, well, I'm entering my name into a form field called name. So I'm AAS, ASI, ASIM. We could have a stream for the X and Y position of the mouse as it moves around the screen in a HTML5 game, the data returned from a real-time WebSockets connection, or the chat windows opened by a user in a browser. In fact, the more you think about it, the more everything we do with a web application can be thought of as a stream. And reactive programming is the idea that you can create your entire program just by defining the different streams and the operations that are performed on those streams. As a concept, that is easy to say, but how can we actually train our mind to program reactively? To explain this, let's convert a simple imperative function into a reactive one. Just a quick note, imperative programming is a programming paradigm that you've probably have been using so far in your career. It's by far the most common and it involves executing statements that change a program's state, such as calling functions that change the values of variables. So we have a function called add and some state variables called A, B, and C. To add A and B together and change the state of C to be the sum, we call the function add. Now let's imagine later on the value of B changes to 4. First, we need a way of simply knowing that B has changed. That's hard enough to figure out by itself. And secondly, we need to know that because B has changed, we need to recalculate C. With a web application, our inputs are constantly changing over time via things like network events or a user interacting with a mouse. Most of the logic we end up writing is just to figure out what functions need to be called for each of these changes to our inputs. Now, I like to think of applications as just a huge pile of variables, which we call application state, as well as logic to decide which functions to call and in what order when any of those variables change. And then calling those functions then also changes the values of other variables for which we need additional logic to figure out what other functions we need to call. It's endless. With reactive programming, however, we stop thinking about variables. Instead, we think in terms of streams and how those streams are connected together. And going back to our example, let's convert the variables A, B, and C into streams. A is now not an individual value at one point in time. It's a stream of values over time. And now the function add we think of as an operation we perform which connects the output of streams A and B to the input of stream C. Now if we push some numbers onto streams A and B, the add operation is automatically called, calculating the sum of 3 and pushing it onto stream C. Now, we didn't call the function add. Instead, we pushed the values 1 and 2 onto their respective streams. And the operator add was called automatically by the framework. Now, if stream C was connected to another stream via another operation, that operation would then be called automatically as well. An analogy which works for me is to think about reactive programming as plumbing. We decide which pipes we need in our application. We decide how those pipes are connected together through operations, and then we turn on the water and sit back. With reactive programming, we don't call functions. We just define how our application is plumbed together and then start pushing values onto streams and then let the plumbing and the operations handle the rest. So if later on the value of B changes to 4, we simply push the new value onto the stream B and then let the plumbing handle the rest. So in summary, streams are just a sequence of values over time. And reactive programming is the idea that we can define an application as a series of different streams with operations that connect the different streams together and which are automatically called when new values are pushed onto those streams. In this lecture, we've just covered the idea, the concept of reactive programming. In the next lecture, we'll cover how to actually program reactively using observables and the RxJS library.